This is called the contingency table. Each row represents the survivor status, either survived or died. Each column represents a demographic group, men, women, boys, or girls. For example, this number here, 334, means that 334 men survived. Over here, 1,360 men died. For women, 318 survived, 104 died. And we also have the numbers for boys and girls. Notice that the totals are missing. We are going to calculate those as our first exercise. Let's begin with part A. Calculate the totals by passenger and survivor status. First, we'll calculate the column totals. For men, 334 plus 1360, that is 1694 men in total. For women, 318 plus 104, 422 women. Boys, 29 plus 35 equals 64 boys. For the girls column, 27 plus 18 is 45 girls. For the row totals, for survived, we take 334 plus 318 plus 29 plus 27 equals 708. For the second row, we take 1360 plus 104 plus 35 plus 18 equals 1,517. And finally, for the grand total, we'll take 708 plus 1517, that is 2225. Or you can also take 1694 plus 422 plus 64 plus 45. You still get 2,225 passenger totals. Now, part B. Calculate the probability of a randomly selected passenger being a man who survived. To find this, we divide the number of men who survived by the total number of passengers. There are 334 men who survived, and 2025 total of passenger. We'll take 334 divided by 2,225. Which is about 0.1501. In this example, I round the answers to 4 decimal places. However, keep in mind that we do not always round to 4 decimal places. Always follow the instructions for the specific rounding requirements. You can leave the answer as decimal, or you can also change it to percent, which is 15.01%. Part C, calculate the probability of a randomly selected passenger being a boy or girl. Since the events being a boy and being a girl are mutually exclusive, we can use this formula, probability of boy or girl equals probability of boy plus probability of girl. There is a total of 64 boys, so the probability of being a boy is 64 over 2225. And there is a total of 45 girls. The probability of being a girl is 45 over 2225. Together, we will have 109 over 2225. And 109 divided by 2,225 is 0.049 or 4.9%. Part D, calculate the probability of a randomly selected individual that is a woman or died. Since the events being a woman and having died are not mutually exclusive, so we use the additional rule. Probability of woman or die equals probability of woman plus probability of die minus the probability of woman and died. So let's look at the table. There is a total of 422 women. So probability of being a woman is 422 divided by 2,225. There is a total of 1,517 deaths. So probability of having died is 1517 divided by 2225. And there is 104 women died. So the probability of being a woman and died is 104 divided by 2225. And that is 1835 over 2225, which is 0.8247 or 82.47%. Part E. Calculate the probability of a randomly selected passenger being a boy given that he died. This is an example of conditional probability. Since we're given that the person died, we consider only the total number of deaths rather than the overall total. Let's look at the table. There are 1,517 deaths in total, of which 35 were boys. So the probability is 35 divided by 1,517. Notice for conditional probability, we use this vertical bar to represent the word given. And 35 divided by 1517 is 0.0231 or 2.31%. And finally, part F. Calculate the probability that if two passengers are selected, at least one is a man. This is an at least one problem, and those are often easier to solve with the complement rule. So step one, we'll find the probability that neither passenger is a man. There are two passengers, and we want to find the probability that none of those is a man. So we are going to take the probability of the first one is not a man, multiplying by the probability that the second one is also not a man. Here is our table. There are a total of 2,225 passengers, 1,694 men, 422 women, 64 boys, 45 girls. The passengers who are not men are women, boys, and girls. So there are a total of 531 passengers who are not men. So to find the probability that the first passenger is not a man, we take 531 divided by 2225. Now we multiply by the probability that the second passenger is not a man. There were 2,225 passengers in total. We took one out already, so there are 2,224 passengers left. There are a total of 531 non-man passengers. We took one out already, so there are 530 left. 531 divided by 2225 multiplied by 530 divided by 2224 is 0.056872986. Step 2, we will subtract this number from 1. And I get 0.9431270714. And if I round this to 4 decimal places, I get 0.9431 or 94.31%.